Good morning, students. Today we will discuss about atomic structure. The existence of atom has been proposed by a Greek philosopher 400 BC. Once again, the existence of atom has been proposed by a Greek philosopher in 400 BC. According to Greek philosopher, the atoms are the fundamental building blocks of matter. Suppose if I am considering any matter, no doubt without atom there is no matter. So therefore what we call here the Greek philosopher, the atoms are the fundamental building blocks of matter. Here, of course, the word atom has been derived from a Greek word, but in Greek language we will call atomio. Atomio means uncuttable or non-divisible. Means if I am taking any atom further which is does not cut into various parts at a time of 400 BC or after some time. But after long time during the research, the atomic theory of matter was first proposed by Joseph John Dalton, and his theory called Dalton's atomic theory. And here also different applications are there. That Dalton's atomic theory was able to explain the law of conservation of mass, the second law of constant composition, and third law of multiple proportions. And we will explain about all these three laws. Well known about law of conservation of mass and law of constant composition and law of multiple proportion. But I will give to you a little information about these three laws, isn't it? Here, the existence of atoms has been proposed by a Greek philosopher in 400 BC. That is our point. According to Indian and Greek philosopher, second point I will give to you. According to Indian and Greek philosopher, the atoms are fundamental building blocks of matter. And now here the word atom has been derived from Greek word, but in Greek language we will call atomio. It means atomio means uncuttable or non-divisible. Non-divisible means which is further not divisible. But after long time, the atomic theory of matter was first proposed by Joseph John Dalton, and his theory called Dalton's atomic theory. The next point I will give to you, Dalton's atomic theory. Dalton's atomic theory was able to explain first the law of conservation of mass, and the second one is law of constant compositions. And third one law of multiple proportions. So first law, the law of conservation of mass. What is the statement of law of conservation of mass? The law of conservation of mass states that mass is neither be created nor destroyed in chemical reaction. So according to chemistry, what I mentioned here, the law of conservation of mass states that mass is neither be created nor destroyed in chemical reaction. But in other words, the mass of any one element at the beginning of a reaction will equal to the mass of that element at the end of the reaction, isn't it? So based on this, I will give to you one statement: the mass of the reactant is equals to mass of the product in a particular chemical reaction. So now I will give to you statement: the law of conservation of mass, it states that mass is neither created nor destroyed, nor destroyed in chemical reaction. Chemical reaction. In other words, we will define the mass of any one element at the beginning of a reaction will equals to the mass of that element at the end of the reaction. So based on this statement, I will give to you one statement. Mass of reactant is equals to mass of product. Mass of reactant is equals to mass of product. Or mathematically, I will give to you mass reactant is equals to mass of the product. So this is about a little information about law of conservation of mass. The second law of constant composition. Law of constant composition. But how can I state this one? So law of constant composition states that in any given chemical compound, the elements always combine in the same proportion with each other. Suppose I am taking here water. Any water molecule is always made up of 2 hydrogens and 1 oxygen atom, and their ratio, hydrogen and oxygen ratio is 2:1, isn't it? I will give you statement. Law of constant composition states that in any given compound or chemical compound, or any given chemical compound, the elements always combine in the same proportion with each other. Example I am taking here, water. So now in case of water, any water molecule is always made up of 2 hydrogens and 1 oxygen atom. oxygen atom, and their ratio is 2:1. 2:1 means this is 2 hydrogen atoms and 1 oxygen atom, isn't it? And next, suppose I am taking here hydrogen peroxide. So in case of hydrogen peroxide, example 2, hydrogen peroxide, their chemical formula H2O2. And here also, if any hydrogen peroxide molecule is always made up of 2 hydrogen atoms and 2 oxygen atoms, and the ratio is 1:1. The ratio is 1:1. That is. And the third one is law of multiple proportions. And it states that when 2 elements combine to form more than one compound, the mass of one element which is combines with a fixed mass of other element will be always ratio of whole numbers. So I will give to you one example about that. So law of multiple proportion, it states that when two elements combine to form more than one compounds, the mass of one element which combines with a fixed mass of the other element will always be in ratios of whole number. So simply I will give to you one example. Suppose I am taking here carbon and oxygen. The combination of oxygen and carbon, I am getting carbon monoxide and carbon dioxide, and the ratio of this carbon dioxide and carbon monoxide is somewhat okay. Like so, this is about law of multiple proportion. And next we will discuss about electron discovery. So without notes, I will explain little bit about that because of it's not in your syllabus. Electron discovery, and well known about models, atomic models. I mean Rutherford model and J.J. Thomson model and Rutherford experiment, and so that's why I'm explain shortcut. Electron discovery. Electron was discovered by J.J. Thomson. And the name electron was proposed by Stoney. So once again, I will give to you one point about this. Electron was discovered by J.J. Thomson. And the second point, the name electron was proposed by Stoney. The experiment of Michael Faraday suggested that a particular nature of electricity. So in case of, in this experiment what we do here, we take one of the cathode tube, and in that cathode tube we will fill a certain amount of gas. Inside the tube, the very low amount of pressure is present and high voltage is applied. If the high voltage is applied, the different cathode rays is arised from cathode and which is moved towards anode. And the cathode ray discharge tube is sealed tube and made up of glass containing two thin plates. That plates what we call electrodes, isn't it? So in our cathode ray tube contains two metal plates. These metal plates what we call just electrodes. During the experiment, the rays pass from negative charged plate to positive charged plate. Positive charged plate means anode. So once again, during the experiment, the rays pass from cathode to anode. Simply I will mention. And the next point about this, important point about this experiment, the electrical discharge through the gas could be observed at only very low pressure, that is equals to 0.01 mm of mercury, and at very high voltage, that is 10,000 volts. And the rays emitted from cathode are called cathode rays. Cathode rays are stream of electrons. And here also different properties are there. I mean about that properties. The cathode rays move from cathode to anode, and these rays are invisible, but their behavior can be observed with help of fluorescent material or phosphorescent material. But in our textbook experiment, we will use one type of material, that is zinc sulfide, ZnS. And what is the uses of this zinc sulfide? Just we know behavior of cathode rays. The cathode rays travel in a straight line in absence of electric field and magnetic field. But in the presence of electric and magnetic field, these cathode rays is deflected towards anode side, isn't it? Suppose I mention here magnetic field. At that situation, these cathode rays are deflected towards south pole. Cathode ray contains negative charged particles, and these are called what? Electrons. And the cathode rays is independent of nature of cathode material and independent on nature of the gas. Therefore the E by m value of electron is constant, and the E by m value is equals to, here also we will shortcut explain about the charge to mass ratio of electron. So charge to mass ratio electron mentioned here E by m, that is equal to, according to experiment I will mention 1.7588 into 10 power 11 coulomb per kg. So per kg, which is converts into grams. So what I mentioned here, same, E by m is equals to 1.7588 into 10 power 8 coulomb per gram. So this is the E by m value of electron. Of course, suppose if I am taking any gas in our cathode ray tube, their E by m value of electron is constant. But at the same way, the E by m value of proton or cathode anode rays is different if I am taking a different gases. How does it means? So my question is, I am taking here E by m value of electron. Electron means cathode rays. And the next one is E by m of anode rays or proton. Anode rays or proton. This is cathode rays or electron. So E by m value of electron or cathode rays is always constant. I mean, if I am taking a different gases in our cathode ray tube, their E by m value is constant. But coming to anode rays or protons, in this situation, suppose I am taking here a different gases, their E by m value also different. But so simply I will mention the E by m value is not constant for different gases. Why? Because suppose I am taking here one of the gas in our tube. I mentioned like this. This is a one tube. So roughly I will mention like this. This is the tube. In this situation, one plate is here and here also one of the electrode. One type of A-type gas is filled. A-type gas. Their mass is X, isn't it? And now coming to E by M value. In this situation, here the gas particles are present. The gas particles are, first of all, when the high voltage is applied. At that situation, this gas molecule is ionized. So therefore, certain amount of electrons are released. At that situation, we get a positive ions. What I am getting here? When I am applying high amount of voltage to the tube, we get the positive charged ions, isn't it? And next, at the situation, this gas has certain amount of mass. And other situation, I am taking here another gas. And here also same electrodes I am taking, and here second electrode. But here, in the situation, I am supplying a B-type gas. B-type gas, and their mass is different when compared to A. Suppose I mention here their mass is Y. Therefore, E by M value when compared to first one, the second one is different. So that's why what I mentioned here, E by M of a proton or anode rays is different for different gases. But E by M of an electron is always constant. Are you follow? Yes. And after that, so next, of course, the subatomic particles, atomic models, I mean Rutherford, J.J. Thomson model, and atomic models and experiments. So it's not in your syllabus, and we will start next class from atomic mass and